In this video, we'll discuss the applications of differentiation. So far we learned to differentiate function using the fundamental theorems of differentiation. Okay? Now, if that function cannot be applied to the fundamentals, then we have the technique of differentiation, which is chain rule and the function raised to n. So today, let us have some application problems on the differential calculus problems application. Okay, we will apply the concept on the profit and also with the areas, volumes, and the time rates. Now take note that in the application of derivative, actually this is good for the rate of change. No? The identifying the rate of change is very much important, and that rate actually is the critical point. So therefore, this is actually using the maxima minima problem. So we have to maximize or minimize the result, and doing it is to find the derivative, then equate that to 0. Because when the derivative of the function is equal to 0, it is where that the slope of the tangent line is horizontal. So if it is horizontal, then it must be the critical points. It can be a minimum or the maximum. So that will be fit on the maxima minima problem. So profit actually is part of the maxima minima problem. Okay, let's start. The problem says that we have the apartment complex and we have the numbers of apartment to rent. We have the 250 apartments. Now, if they rent X apartment, meaning number of apartments is actually X, then their monthly profit in pesos will be given by a function. So this will be the study, feasibility study of the business, that the profit can be obtained using this curve. And we have the negative 8x squared plus 3,200x minus 80,000. So this will be the mathematical modeling of the profit. So they come up with this analysis. Now the question says how many apartments should they rent in order to minimize or maximize the profit? Because in the profit, we are concerned with the maximum result of the business. So if you are the owner of this business, you are concerned with the maximum profit. So if this model is the result in the study, so therefore this must be followed in order to come up with the maximum profit. Now remember that if all apartments was rented, let us say 200, 250, so we cannot expect that it is the maximum profit. Surely it will be minimum because this is a curve downward. Okay, so we are looking for how many number of apartments should be rent in order to come up with the maximum profit, and it should be the highest point of the curve. Take note, this is a parabola. Parabola, because this is second degree and this is negative 8, so the parabola is open downward. So there must be a highest point to that, and that will be the critical point. And we are to look at that point, the maximum point. And the maximum point of that curve is actually the maximum profit. How many apartments should be rented in order to produce a maximum monthly profit result? Okay, so in this solution, we will be looking at, because when we say maximum, you have to find the rate of change. Okay, so it should be the change of the profit with respect to this number of apartments to be rented. So we have dp over which means that we have to differentiate this. Okay, from this profit, take the derivative of this. Now, when you look at the function, this is very simple. No, we can. This is just basic using the sum rule. So, take the derivative, dive in the two. So, this become 2 times 8, negative 16x, and this one is 3,200. Okay, so take the derivative of that using the sum rule. Again, we have this as negative 16x and 3,200. Okay, so that's it. Run. Now, we need to equate this 0y. In order to provide, take note, this is the slope of the tangent line, the slope of the profit function with respect to x. So in order to obtain the maximum, the highest point, because at any point, we have the slope, the curve. Now, when that point reaches to the maximum point, the derivative of that function must be what? The derivative of that function with respect to x must be horizontal in order to provide the maximum. So if the line is horizontal, then the slope must be 0. Then the rate of change must be 0. So we need to differentiate the dp dx to 0 or equate to 0 in order to produce or in order to optimize. So when we say optimize, optimum points, it can be minimum or maximum. So the minimum and maximum point can be obtained by equating the rate of change to 0. So in this case, this is maximum. Okay, this is maximum point. There is only one critical point in the quadratic, and that is the highest point of this curve, parabola downward. So therefore, equate to 0. So therefore, by equating 0, we think of a horizontal line. So the slope must be 0. Okay. So with that, equate to 0, you can solve for x. And take note, this is the requirement. How many apartments should be rent in order to have a maximize or to maximize the profit? So therefore solve for x, transpose this one to the left side, then divide both sides by 16. The answer is 200. So out of 250 apartments, they need only 200. Okay, why? Maybe if there are many rooms that operates during the time, maybe it has a greater expenses. No? So this is based on their study. So with this, we are able to obtain the optimum number of apartments that can be used, and that is only 200. So if you are uh, doing this business, do not provide 250 apartments. Instead, construct only 200. Okay? That's it. This is the profit problem. Now, next is we have the area. So, there are many problems, no, in everyday life that the calculus be applicable. So, this is only one of that, and we have the area. So, the question is, find the dimensions. So, this is looking at the dimensions of the rectangle. So, take note, rectangle is a four-sided polygon, no? Whose vertex has an angle of, a vertex is an angle of 90. So four-sided polygon. We have the length and the width. Okay. So the perimeter is 1,000. So take note, the perimeter is the sum of all the sides. So that the area of the rectangle is maximum. So you are now on the way to solve if your perimeter of that area of the rectangle is 1,000 and you want a maximum area. Okay, you want the maximum area. What should be the dimension of that rectangle? Okay, so that will be the equation. So suppose this is the rectangle. Let us say this is farm area. Okay, so you need to have the fencing activity or project, and you have only 1,000 length meters of fence that is available in your supply. So what will be the area suppose you have a large area here and you want to buy only based on the available fencing material, which is 1,000, what will be the dimension? So what will be the X and what will be the Y? Okay, so to do it is, you have to use the 1,000, okay, as our reference point. And take note that the question is, in order to provide a maximum area. So in this case, the maxima minima will comes into what? To the area. So you have to find the rate of change of the area with respect to any of this variable. Okay. So you have to formulate the area. And after that, you have to include the x and y involved, x or y. Okay. Then with that, you have to differentiate the area. So once you are differentiating, again, you have the rate of change. So if you have now the rate of change or the derivative of that function of a, then because this is maxima minima, and this one we are looking for the maximum, so we have to equate to 0 again, because equating to 0 is the optimum result. Okay, so again, first is start with the perimeter, and the perimeter, take note, is the length of the two sides, which means that if this is x, let this be one side of your fence or rectangle is x and the other side is y. So we have what? Perimeter should be x plus y plus x plus y. Okay, so it should be 2x plus 2y. So the 1,000 should be divided by the 2 times x and the plus the 2 times y. Okay, so with that, we can solve for y. Or you can solve for x in terms of the other. So let's say I will solve y in terms of x. So therefore, if you are looking for the dimension of what is y equal to, you should know what is x. If you know x, you know y. You can calculate y. Take note, we are asked to calculate what is x and y. So this one will be our relation, pair of relation. Y as a function of x using the perimeter. So perimeter now is out of the scene. And this is now involved x and y. Now what is area? We have to formulate the area because it is the area that we will find the derivative and equate it to 0. What is area? Take note that in geometry, area of a rectangle is the length times width. Or it should be x times y. Okay? So it should be x and x times y. But y, take note, is 500 minus x. So therefore, it should be length times width. So it should be x times y, but y is 5 minus x. Okay, that's it. So with that, okay, then we can distribute, okay. Distribute in order to make it simple, or you can use when differentiating, you can use the product rule, but this is the simplest form. So distribute x becomes 500x plus x squared. Then take the derivative of x with this derivative of this area with respect to x, because the variable here is x. So I've said it should be any x or y, so we can replace in terms of y or in terms of x. So the derivative is very simple by using sum rule and the power rule. So we have the 5 plus 2x. So this is 500 plus 2x. This is the derivative. Okay, this is the rate of change. Take note, derivative means the slope of the tangent line tangent to this curve and this function. By the way, this is area. So the area again is a parabolic, but this is open upward. So if you are looking for the maximum value, okay, or maximum area, okay, then you have to equate this to 0, because again, equating to 0 is to obtain the critical point. Now in this case, a parabola is open upward, then it follows that it should be minimum. In equating to 0 is minimum, but it will provide a maximum area. Okay, so then equate this to 0 again, then solve for x, and x now is 250 meters. So therefore, x must be what? First dimension is x is equal to 250 meters. Now y therefore is 500 minus x, but x is 250. So therefore, Y is 250 also. So therefore, your area must be what? Must be a square. If you want to have a greater area maximum, make sure that your area is in a square. You are creating a large or maximum area from the 1,000 perimeter fence. Okay? Now, let's just apply the derivative on the volume. So, this problem is talking about the construction of open box. So, we are about to construct a box, open box. Now, the dimension of the material, this is from the sheet of the cardboard. So, we will provide the open box from the cardboard sheet, which has an amount, dimension of 10 by 15 centimeters. So, the width is 10 cm and the height is 15. Okay? Then, since we are constructing the open box, then we have to cut small squares on the edge of the cardboard. Okay? At the corner of the cardboard, it must be cut by squares, small squares. Now, if you cut the four corners of the cardboard with the square, it should be the same. No? Then you are forming an open box when you fold it up of the sides. And with the sides, okay, and the dimension of your small square cut from the cardboard will be your height of your box. Okay, so the question must be in this way: what is the side? Okay, what is the side length of the small square that we will cut from the corners of the sheet, the box? If the box is to have a large volume, okay, so gusto ka nga, you want to create a volume coming from the cardboard, whose dimension is 10 by 15, and it should be a maximum volume. Now remember that when you cut it, depending on your cutting, you will arrive the volume. Not all sides that can be cut at the corners that provide a large volume. It depends upon your cutting square at the edge. So how much is the dimension of that corner? Okay, that will be the problem. So take note that be careful in maxima minima. You have to be careful in the problem. The question is what is the meaning, because we want to maximize the volume. So the volume must be, we have to model the volume. That's why we have the topic of the modeling. We will find the volume in terms of its dimensions. Okay? It should be in terms of x, because we are looking for the what will be the side x, or the x, the side of the cutting small square at the corners. So we have to formulate the volume, and should be expressed in terms of the variable x, where x is the side of the square. Now after that, you have to differentiate the volume, then equate to 0. Because our concern is the large volume. So it should be critical, maximum, minima. Okay? So therefore, for the solution, by the way, this is the problem. This is the cardboard. It has a dimension of 10 cm, and we have the 15 cm. So this is according to the problem. And we want to construct an open box. Okay, an open box. So how will you form a box on this cardboard? The only way is to cut, diba? You have to cut a square. We don't know what is the side of the square, as long as it is a square. You are required to have it a square, so that when you fold it, then you have the same height of the box. So therefore, whatever square cut at this side, at this corner, should be the same square on the other side, and the same on the other, and the same on the last corner. So these are the cutting parts of the cardboard. So when you cut this part, then you have to fold here, you have to fold at this point, fold this one, then you have to orient that sides up. So therefore, x must be the height of your box. and you are forming an open box. So let that be equal to x. We don't know how much is that. That's why, by the way, if your square is too small, maybe your volume is small. Now, if it is too large, your volume must be small. Now, there must be a value of x that will provide a maximum volume. And what will that be? So what is x in order to provide the maximum volume? Okay? So again, when you, by the way, if this is x, and this is x, now take note, this is 10 centimeter. So the 10 centimeter was cut by 2x's. So there are 2x that can be cut from the 10. So it should be 10 minus 2x. The remaining length of the 10 centimeter becomes 10 minus 2x. We don't know x, remember? Okay. Now what about in the side of the 15 centimeter? The 15 centimeter was cut by 2x's again. So the 15 was subtracted by 2x. So this is only 15 minus 2x, while this one, and this is the 10 minus 2x. Remember, this is very important. Why? Because these are the sides of your box, the length and the width. This is the length, and this is your width of your box, and your height is x. So when you fold it, okay, this invisible line will be the part that will be pulled. Then after that, this will be the box. Okay, so take note, this is your x. This is your x. The cutting part, this part here, will meet at this corner, or this side also. So when you attach these two sides here, then you will have the open box, also with the other side. Okay, so what are the dimensions? This is x, the height of the box. The length of the box is 15 minus 2x, and the width is what? 10 minus 2x. So these are the dimensions of your box. Okay, now take note that again we are forming the volume. So what is the volume of this box in terms of x? So length times width times height. Volume of rectangular prism. Geometry. So the length is 15 minus 2x. The width is 10 minus 2x, and the height is x. So multiply the 3. The 15 minus 2x, 10 minus 2x, and x. This will be the volume of your what? Of your box, open box. Okay, so then we have to differentiate the volume with respect to what? We have to differentiate the volume with respect to x. Why? Because we want to know the rate of change of what? Of the area, of the volume. Because you are to find the maximum volume. So in order to provide maximum volume, you have to differentiate that and equate that to 0. Differentiate with respect to x and equate that to 0 in order to come up with a maximum volume. Okay? So with that, by the way, for simplicity, you can distribute this so that you have only 2 factors to make it simple. So then we can apply the product rule on this by differentiating. So dv over dx is copy, di ba? One at a time. The derivative ub is v du plus u dv. Okay, so one at a time. So copy, then take derivative. Now this time copy this one, then the other must be differentiated. So then power rule and sum rule, again combination. So this is part of the answer, So this one, this must be sum rule, okay? So with that, the answer is 10, this is 4x, this one is 15 is 0, so we have only negative 2. So with that, simplify further. Now this is now the rate of change with respect to x. Now in order to have a maximum volume, equate that to 0. Okay? Equate that to 0. Then solve for x. Now, solve for x, and this would be the answer to the problem. What must be the side of the length of the squares in the box? Now, by the way, this is a quadratic. Okay? So, there must be 2 answers on this. And there is only one answer will be presented. Because the other must be impossible to do it. Let's say, that's all. So, how to solve this one? Now, you have to recall your algebra using quadratic formula or factoring, or it's possible for factoring. But I think this is good if you have the formula, quadratic formula. So remember your formula, the x is negative b plus or minus square root of b squared minus 4ac divided by 2a. So your a is 12, your b is negative, 100c is 150. So negative b plus minus square root of b squared minus 2ac over 2a. So then substitute, simplify, we will come up with 6.37 centimeters as for the one answer, and the other answer is 1.96. So what do you think? Which will be the correct answer? We have only one answer to this. It's either 6.35 or 1.96. Okay. To analyze is, look at this one. if you use the 6.37 for x, look at this one. Our dimension of the cardboard is only 10 centimeter by 15. So on this side, if you have to cut 6.37, so your 10 centimeters is not enough. Did you see the reason? So if this is 6 centimeters, 6.37, you have to cut it 2 times. So you are cutting already 12 point, okay, or 12.74. It's more than 10. Okay, so therefore this is impossible to happen. But if you have to cut 1.96, it's good. Okay, it is twice this side is we still have the length, the width of the box. Okay, so this is the answer. Okay, so aside from the rate of change, by the way, maxima, minima, we can also use the principle of derivative. In fact, this is very important. Why we study calculus? Because we want to prepare ourselves in physics. So in rectilinear motion, when we say rectilinear motion, the particles move in a straight line. Okay, so when the particles moves in a straight line, where the distance is equal to displacement, it is called as a rectilinear motion. Now, the displacement is assigned as xt. We can assign displacement is as a function of time. So this is just an assignment. So, for example, the particle moves at that point, then certain time it was displaced at that another point. So the displacement is actually or the position, because the change in position actually is the displacement. So in this case, we assign s as the position of the particle from some point of reference. So initial point, final point. It should be expressed in s. Or sometimes we use x. Okay, so it depends upon the author. Okay. Now, if we have the position, which is a function of time, if we take derivative of that position with respect to time, the result is velocity. And we call this as instantaneous velocity. So, very important as yan. If you want to know what is the instantaneous velocity or the velocity at that instant of time, then take the derivative of the position. So therefore, if very important is the position. If you have the position, which is a function of time, then you can always find the derivative. Take the derivative of that with respect to time, or the s prime t, called as the instantaneous velocity, or symbol v. Okay? Or the first order derivative of the position is the velocity. Now, while the second order derivative of that, if you take the second order derivative of the position, it is the instantaneous acceleration, or a. Okay? Or the first degree or first order derivative of the velocity with respect to time is the acceleration. But remember that velocity is the change in position of position. It is the derivative of position with respect to time. Then it follows that acceleration is the second order derivative of the position. That's it. Okay? So these are very important terms if we are dealing with the problems in rectilinear motion and we want to engage the calculus. We are forced to study the terms, no? The position, the velocity, and the acceleration. And you have to memorize this process. That the derivative of position with respect to time is velocity. The derivative velocity with respect to time is acceleration. Or the second order derivative position is the acceleration. Instantaneous acceleration. Remember that we have the average velocity and we have the instantaneous velocity. The instantaneous velocity is the velocity at that instant. But the average velocity is talking about the two time interval. So given the time interval, let's say 2 seconds to 5 seconds, how much is the velocity? And that is the average velocity. But in this case, we can obtain the instantaneous by having the principle of calculus. That's the power of calculus. It's difficult to use algebra base to obtain the instantaneous. The problem becomes simple if we have the differentiation process. Okay, that's it. So, prepulling bodies. Aside from that, rectilinear, prepulling body is a kind of rectilinear because it is moving up and down. So in this case, we have the assumptions that we will ignore all effect that present in the surrounding. So we have only the effect. The motion of the particle is due to the Earth's gravitational acceleration only. So it is only the Earth that affects the motion of the particle. So we call that as freely pulling body. We ignore the other factors like the rotation of the Earth, okay, the gravitational pull of the other particles of the moon or the other components present in the areas. So we ignore it and we concentrate only on the force of gravity or the force that attract to any object due to the Earth's attraction, which it has an acceleration of 9.8 or 9.81 meter per second squared. Then we call it as a freely pulling body. That's why any particle that is placed above the surface will move towards the surface. Why? Because it was being attracted by the Earth. The Earth has the largest mass, so it must have the greatest amount of force. All particles must attract to each other, must attract to Earth. What goes up must come down. Okay? So ignoring all aside except the Earth's attraction, they will call it a pre-pulling body. So the advantage of here is we are already given the acceleration, which is 9.81. So that's the advantage of that. Okay, so that's it. So let us have the example. Now, given the position vector, we call this as a position vector is, no? Why? Because it is coming from the reference. So everything that's coming from reference is called as position vector. So based on the problem, given the position t is a function of it is t cubed minus 12t squared plus 36t minus 24 in meters. Okay, because this is position. The question is calculate the following. Letter A, instantaneous velocity after traveling 5 seconds. So the velocity at that instant where the time is 5 seconds. How will you do it? Letter B, the instantaneous acceleration at the same time. So calculate the velocity, then after that calculate the acceleration. Letter C, time that the particle travels that provides a rest position, which means that in what time that the velocity is at rest, or the particle is at rest. So the only way that the particle is rest when the velocity is zero. So therefore, you have to equate the velocity to zero. Now remember, the velocity is the rate of change of the position. So take note, when we say rate of change, it is the derivative with respect to the other. The rate of change. So therefore, that's why acceleration and velocity are the rate of change. So those are uh, the derivative of the position with respect to time, because they are all rate of change. So in order to provide the rest velocity, take the velocity, then equate to zero. Okay, that's it. So solution. Letter A, how to produce velocity? Again, take the derivative of position with respect to x. So you have to differentiate the position with respect to x. Now our s is t cubed minus 12 t squared plus 36 plus t minus 24. Then sum rule, very easy. This will become 3 t squared, and this is 24, 36. Okay, that's it. Now after that, because you are asked to find the velocity in 5 seconds, so t must be substituted by 5 seconds. Okay, so with that, the velocity at 5 seconds, the answer is -9. So what's the meaning of -9? The negative 9 means the particle is already in its way back home. So it will change its direction, return to the original position. So the velocity is now in the direction from the towards the initial point. So okay, so that's it. Reverse direction. Now for letter A, you have to differentiate again. You can differentiate the velocity in order to produce the acceleration, or take the second order derivative of position. There are two ways to answer, but I think it's better to use the velocity. So find the velocity, use the velocity, take derivative velocity with respect to time, set, then do it. Take note, this is the velocity with respect to time. Do not use this one because this is already the velocity at the 5 seconds. So use the as a function of time. That's why take derivative of that, constant straight, right? So we have 60, then we have 24 because 8 times 3. Then substitute with A is equal to 5, then we have 6. So the acceleration is 6. And the unit, take note, is meter per second squared. And the velocity unit is meter per second. Why? Because this is position with time. But the acceleration is the velocity with time. So the unit velocity is meter per second. You divide it again by seconds, so it must be square. Okay? Letter C. So what will be the time that the particle will be at rest? Now, since we need to equate the velocity, di ba? We need to equate the velocity to 0, and the velocity is a second degree. Second degree. Take note, this is a second degree. There are 2 times that the particle is in at rest. Okay? So this one equal to 0. So this will be eliminated. If you divide both sides by 3, this will be removed. Then solve the value of t by equating this everything by 0. So take note, this is already 0. So t minus 1 or minus 2 must be equal to 0. And also t minus 6 must be equated to 0. So solve for t. First answer is 2 seconds. And the next answer is 2 seconds. So there are 2 answers. Actually 3, no? When t is equal to 0. No. When the position, the particle is at rest at 2 seconds. Then after that, 6 seconds also, it will. This is where that the particle will be at rest. The 2. So again, we have 2 answers to the problem. So thank you for listening. So see you in my next video.